So shall we start? Vishnupriya,
Ma'am,
what about others? Join karibe na nahi?
I don't know, ma'am.
So we'll start now, okay?
Yes, ma'am.
Okay. So in the last class, I have discussed about logical connectives like conjunction, disjunction, implication, negation, and equivalence. And I have already discussed that what can be the truth values of these compound statements that will connect with these connectives. Okay, so while we are trying to deal with everyday language and trying to symbolize those language through certain logical symbols, okay, and by using logical connectives, there we need to be little careful about what are the words that will help us to identify which kind of connective we are going to use. Okay, so for example, uh, when we are trying to symbolize the compound statements involving the connective conjunction or and, they are certain words like moreover, furthermore, but, yet, still, however, also, nevertheless, although, and so forth, and even the comma and the semicolon are also used to conjoin two statements into a single compound one. And all of them can be indifferently translated into the dot symbol or and conjunction so far as truth values are concerned. So that means in the statements or in the compound statements, if we find the words like moreover, furthermore, but, yet, still, however, also, nevertheless, although, etc., etc., they are what kind of connective we are going to use? We are going to use the connective conjunction, right? So, these are the signifying words by which we can use the symbol conjunction. Likewise, when we are getting a negative propositions, okay, where we need to use the logical connective as negation, hmm, there what kind of uh, words or what kind of words will signify the negation or the denial or the contradictory? Suppose, for example, we are having a statement like, it is false that lead is heavier than gold. It is false that lead is heavier than gold. Here, we are denying the proposition lead is heavier than gold. Okay, so if we will symbolize this particular proposition by a alphabetical letter P, okay, then what will be the symbolic form of this proposition? The symbolic form of this proposition will be negation P. because the statement that we are having is it is false that lead is heavier than the gold. Okay. Similarly, suppose we are having a proposition like it is not true that lead is heavier than gold. Okay. Here also we are symbolizing the proposition as negation P or negation L. So the proposition need to be symbolized by a particular letter, and accordingly we have to see that whether this is an affirmative statement or a negative statement. Okay. So these are the two explanations about conjunction and the negation operator, or the conjunction and the negation connectives. I'm repeating those who have joined now. Okay. So I was saying that when we are trying to symbolize a compound statement, the compound statement which is being connected by the logical connective conjunction or and, okay, which is symbolized as a dot, there are certain words we can find in a statement which will help us to identify or to signify the how we can use the, or how what kind of logical connectives can be used in case of a conjunction. Okay, if a statement involves the words like moreover, furthermore, but, yet, still, however, also, nevertheless, although, and so forth, and even the comma and the semicolon are also used to conjoin two statements into a single compound one. Okay, so these are the very signifiers, or these are the marks by which we can symbolize a compound statement by a logical connective conjunction. Am I clear to everybody?
Madam, mm, so these statements, various words like moreover, but, yet, still, but what is there a symbol for different symbols or the same
Now,
symbol
these
that?
are the, if you find these words in a proposition, then they are what kind of logical connectives we are going to use. Okay,
So
so the
all these
logical,
are conjunctions.
yes, all these are conjunction.
So we will use dot for this.
Yes.
Okay.
Okay. For example, let me give you um, an example of this here in the book. Okay, we will discuss it later. So now let's move towards the symbolization of the disjunction operator, or the disjunction connective. I have told you that disjunction is of the form of either or. Okay, so either or is symbolized by the logical symbol V, or which is called as vel, VEL. Okay, suppose we are having a proposition, the United Nations will become more responsible, or there will be a third world war. Are you getting the example?
Yes.
The United Nations will become more responsible, or there will be a third world war. So here we are having two simple propositions connected by a logical connective or. Okay. So one proposition is the United Nations will become more responsible. Another proposition is there will be a third world war. So these are two propositions which are connected by the logical connective or. So let us symbolize the first proposition. The United Nations will become more responsible as N, and there will be a third world war as W. Okay? Are you getting me?
Yes.
Okay. So what will be the symbolization then? The symbolization will be N or W. Okay.
Okay.
Okay. So this is the symbolization form of the logical connective disjunction. Another very significant point is the negation of a disjunction is often expressed by using the phrase neither nor. So, what will be the negation of the disjunction? Negation of the disjunction is often used by the phrase neither nor. So, if you find any proposition involving the phrase neither nor, then it will mean that it is the negation of the disjunction proposition. For example, let me just share with you the screen to explain what I want to say. Is it visible to everybody? The screen?
Yes, it is visible.
Okay. Suppose we are having a proposition that neither Alice nor Betty will be elected. Okay? Now, is it visible?
Yes.
Okay. So, how we will symbolize it? So, let's symbolize. So, this is a compound proposition involving two proposition. Alice will be elected and Betty will be elected. So these are the two propositions. So let's symbolize Alex will be elected as A and then Betty will be elected as B. Okay. So as this is a negative proposition, neither Alice nor Betty will be elected. Therefore, as I have told you that neither nor will be symbolized as the negation of the disjunction operator. So here the symbolization will be the whole negation of A or B. Okay? Okay?
Yes.
Okay. Now suppose we are having another example. Alice and Betty Alice and Betty will not both be elected. Will not both be elected. So here how we are symbolizing it. Tell me which kind of connective here we will use. Which connective we will use?
Um, Conjunction, negation of
Yes,
conjunction.
conjunction we are going to use because here we are having the word and. Okay, and this is a negative proposition, not is here. Okay, so when not occurs, the word not occurs before the word both. Okay, when the not occurs before the word both, then we will symbolize the proposition in the way that the negation will be the negation of the whole of the proposition. Therefore, whole negation A, conjunction B will be the symbolization of this statement. Am I clear?
Yes, it is clear.
Okay. So what will happen if not will occur after the both? After the word both. Okay. There the symbolization will be not the negation of the whole proposition, neither the negation of the individual propositions. Negation A, conjunction, negation B. Am I clear now? Is it
Yes,
clear?
yeah.
Okay. So remember this. Now suppose there is a word called unless. So if any statement that involves the word unless, for example, unless more recycling of materials is effected, our resources will soon be exhausted. Okay, what is the statement? Unless more recycling of materials is effected, our resources will soon be exhausted. So here there is the word unless, and if there is a word unless that is found in a proposition, then the proposition will involve the logical connective disjunction. That means it is a disjunctive proposition. Okay, so let me just write down the example. Unless more recycling of materials is effected, our adjusted. So this is the proposition. Okay, so more recycling of materials is effected. This is one proposition. Okay, then our resources will soon be exhausted. This is one proposition. Okay, so this will be symbolized as less. Let's symbolize more recycling of materials as M. Okay, and our resources will soon be exhausted as E. And as I have told you, this is a disjunctive proposition. Therefore, we need to use the symbol disjunction to symbolize this. So this will be M or E. Is it clear?
Yes, it is clear.
Okay. Acha. Just to verify whether you understood it clearly or not. Do you remember the truth values that we have discussed in relation to the conjunction, disjunction, implication, equivalence, negation? Do you remember?
Yes, ma'am.
So P conjunction Q, what will be the truth value of conjunction? Please quickly tell me. Please tell me quickly.
It's true.
No, what will be the truth value of P conjunction Q? How we will decide it?
Uh, Both need to be true.
Yes, otherwise,
It will be false.
very good. What will be the truth value of P disjunction Q?
Uh, it's or statement, so uh, it should be either one should be
Yes,
true.
yes, yes. Then what about implication?
Only antecedent true, consequent false.
Then
Then it will be false.
otherwise it is
True.
true. Very good. P equivalence Q?
When both have similar value, then it is true, otherwise false.
Very good. Thank you. So let's move on. Write down what I am going to say. Suppose we are having A and B are true. Okay? And X and Y are false statement. Did you get it?
If A and B are true and X and Y are false statement.
Yes. Then what will be the truth value of this statement? Can you see it? Write it down. Suppose we are having A or, okay, then X conjunction B or B or Y. Tell me what will be the truth value of this proposition. See. Here we are having three connectives. Okay, actually two connectives, but disjunction has occurred twice and there is one conjunction. Okay, here the determining connective will be disjunction. This will be the determining connective by which we will decide what will be the truth value of this statement. So as I have told you that A is true, okay, then we are having X as false, then B as true and Y as false. Okay, so here what we need to do, first we have to decide the truth value of B or Y. So B or Y will be true. Yes
True.
or no?
Yes.
Yes. Then what will be the truth value of conjunction? Here conjunction will be decided by the truth value of X and the truth value of B or Y. So B or Y truth value we are having true and the truth value of X is false. Okay. Therefore the conjunction will be
False.
false. Very good. Then the truth value of this disjunction will be decided by the truth value of A and this conjunction. Okay. So truth value will be true.
True.
Is it clear to everybody? Please tell me.
Yes.
Then you do yourself one. Write down. Put a square bracket first, then X, disjunction, bracket A conjunction Y, A conjunction Y will be within the parenthesis, then the square bracket ends. Okay, are you able to do it?
Yeah.
Then I'm just trying to write it down. Okay, please tell me what will be the truth value of this. This is not B, this is disjunction. Okay, Quickly do it. Is it done? Amrish,
I'm doing, ma'am. It's true.
how? How?
So, mm, in the first square bracket, uh, it is false, disjunction bracket close, true conjunction false. So, true conjunction false is false, and false disjunction false is true.
Okay, let me check.
False,
See,
a false disjunction false will be false. Okay, false. So it is false.
so you got the truth value as false or true?
False, false.
Okay, right. So here you have to write as this is false, right? This is
Yeah.
false. What happened? It's not. Why it is not going? Okay, the truth value of x is false here, and the truth value of a is true, and truth value of y is false. Okay, so here a is true, y is false, the conjunction is false. Am I audible?
Yes, yes,
So here x is false and conjunction is false, therefore the disjunction will be false.
yes.
Okay, so here also we are having x as false and a as true, therefore the disjunction will be true. And here both x and y are false, therefore disjunction will be false. Okay,
False.
so here disjunction is true and here disjunction is false, therefore the main disjunction here the disjunction will be true,
True.
and the negation of this whole will be
False.
false. Okay, so here we have got false and here we are getting false, so the disjunction will be false.
False.
Yes. Okay. Okay, so let's move to another statement. Now we are going to symbolize the statements, like suppose it is saying that let's abbreviate or let's use the words or the sorry let's use the word letters a b c d, capital letter a b c d. Okay, capital letter a b c d we are going to use to symbolize certain statements. A will be symbolized as or abbreviated as Atlanta wins their conference championship. Okay, and the letter B will be symbolized for Baltimore wins their conference championship, and the letter C stands for Chicago wins the Super Bowl, and the letter D stands for the proposition Dallas wins the Super Bowl. Okay, so these are the propositions and their abbreviations. So A, B, C, D letters stands for these four propositions. Now symbolize this one. Either Atlanta wins their conference championship, and or Symbolize this one. Will you be able to do it?
Yeah, 1 second. Atlanta. Bracket A dot B disjunction C.
Which will be within the bracket? What will be the main connective?
Atlanta and Baltimore will be within the bracket,
Hmm?
and disjunction C.
Yes. Yes.
Okay.
So this will be A,
Dot B.
sorry, A dot B. This will be within the bracket. Okay.
Mm.
Then we will have C. Okay. Says
Yes.
you can see it, the starting word is either. Therefore, it is quite clear that either has finished here before the word Chicago starts. Okay. So and lies in between. Therefore, the main connective will be disjunction. Symbolize this one. This one.
Uh, A uh, bra- negation of
Hmm?
um, negation of then bracket,
Hmm?
then again negation A dot B.
Yes. So negation A dot B. Okay. So negation will be what?
Negation will be true. Like
Yes. So that means, suppose for example, we are having P as true. Okay. We are having P as true. So what will be the negation of the no negation of the P? It will be
false.
false, right?
Mm,
So what will be the negation of negation P?
true.
It will be true. Then what will be the negation of P?
False.
False. Okay? Okay. So far it is clear, na?
Yes.
Acha. See here, another very important point that is there, all there in your syllabus also. The distinction between argument and argument form. The distinction between an argument and argument form, and similarly the statement and the statement form. Okay. Suppose let me start with explaining statement and statement form. Here in the in this example, Atlanta wins their conference championship. This is a statement, and this statement or proposition is symbolized by the capital letter A. Okay. So this is a statement. Okay. And here also, when we are trying to symbolize this compound proposition, here also we have used the capital letters to symbolize this. And these capital letters, they stand for the statements. Okay. Suppose we are having a similar form of statements. For example, we are having A conjunction B or C conjunction D or A conjunction A conjunction C or D. Okay. Or we are having S conjunction M conjunction E, etc., etc. Here you can see that all these four propositions, even if they are different proposition, but they are having the same form. Okay. So in order to understand the form of this proposition, we need to understand, or we need to symbolize all these statements into a common form by using the individual variables. By using individual variables. Okay. And the letters like, for example, P, Q, R, S, etc., they are used as individual variables. So, all these statements are having the similar form of conjunction, therefore, they will be symbolized as for example, P conjunction Q. Okay. So here, in this case, A conjunction B, P stands for the statement A, Q stands for the statement B. Similarly, in this second statement, P stands for the proposition C and Q stands for the proposition D. And in the third one, P stands for the proposition A and Q stands for the proposition C or D. In the fourth one, P stands for the for the statement S and Q stands for the statement M conjunction E. Am I clear?
So form is just to represent the main connective.
Yes. Form is to no, it is not to represent the main connective, rather it is to represent the form of the statement.
Okay.
Okay. So here, while there is a statement, there we can have a different letters or several different letters to represent the proposition, but when we are talking about the form of the statement, there we need to use the individual variables to represent it. Okay. So here you can see that Q may stand for a simple proposition and it may stand for a compound proposition as well. And similar can be the case with the proposition P. So P may stand for a simple proposition or it could stand for a compound proposition as well. Am I clear?
Yes.
So that is the very difference between statement and statement form. Okay. Suppose now this, if this is used in a form of an argument, suppose in an argument we are having, as we have already discussed, argument contains statements or propositions. So If there is the argument, there is statements, and we have symbolized them into capital letters, then we need to symbolize these statements uh, into the individual variables to represent the argument. So that will be the form of the argument. Okay, so the argument contains statements and the argument form contains statement forms. Am I clear?
Yes.
Okay, let me give you an example. Suppose we are having one argument U or W, first premise, then the second premise we are having U, and in the conclusion we are having. In the conclusion we are having W. Okay, here it just comes into this form. Oh god. Yeah. Therefore W. Okay, so now this particular argument can be symbolized as, what will be the form of the argument? P or Q, which will be in the short form, then negation P. Therefore you can use the symbol here, I am not able to do it. Therefore Q. Okay, is it clear? Please tell me.
This you are showing how to write the statement form.
This is the argument. Okay, the argument contains what? The statements.
Yeah.
Okay, so here each of the statement can be used as a statement form, so as the statement form will be contained in the argument form. Am I clear or not?
But why we are doing this? Because we just changed the representation in small, like P and Q in variable. Like we represented the it in terms of variables,
Yes, we
isn't
have
it?
to represent it in terms of variables so that it will be easier for you to remove the misunderstanding from the statements. Okay,
Uh,
gradually you will get to know why these are to be
are
done.
are we removing the details of the statement and highlighting the main
Yes,
one?
tell me.
Okay. What I thought that we are, we are using variables only to show the essence of the statement. Their, mm,
Yes, yes, yes. Suppose there are different statements as I have discussed here. There are different statements, but here we by replacing them with individual variables, we are having a common form of all these different statements. Okay, so we have reduced by using the individual variables in place of statements to a common form of it. So if you are being asked that what is the form of these statements, you will answer that the form will be the P conjunction Q. Here, one may say that P may stand for a compound proposition in itself or a simple proposition in itself, whereas Q also may stand for simple or compound statement. But here, we are not actually identifying what statement P stands for or Q stands for. Rather, we are simply showing the common form of the all the statements. Am I clear?
yes, this part is clear.
Okay. So if you are having, uh, let me just click a photo, then I will share it with you. Amrish,
Yes.
do one thing for me.
Mm-hmm.
You just, you have my number, right?
Yeah.
Just a minute, just a minute. So here I am sharing one thing with you. Just have a look here. Just a minute. It is very difficult to teach symbolic logic in online mode. God. Can you see this page?
Yes.
Can you see this page? Okay.
Yes.
See, in question number 1, okay, in question number 1 or exercise I, all these are all these are arguments involving statements, okay, and in double I we are having the argument forms, okay. So here you have to match which argument in exercise I matches with the argument form in the exercise double I. Can you see it?
Yes. Yes.
For example, see the exercise IA. Here we are having the argument, the premise A and the conclusion A, disjunction B. Okay, so here see this fourth one in double I. So this is the similar form, is not it?
Yes.
Okay, can you do it?
Yeah.
Please match the B.
That is one.
Yes, very good. So that is what I am trying to say. Okay?
Okay.
Pankajini, ବୁଝି ହଉଛି?
Yes, ma'am.
ବୁଝିପାରୁଛ ନା ନାଇଁ ବୁଝିପାରୁନ?
ହଁ ma'am, ହଁ.
ବୁଝି ହଉଛି, ହଉ. Okay. So now let's move to another another explanation, which is on doing the truth table. Okay. So I have told you what will be the truth value of these logical connectives, okay, involving conjunction, disjunction, and your implication, equivalence, etc. Then we will do certain uh, statements and arguments and trying to find out the truth value of these statements. And while we are doing this, the kind of truth value, what kind of truth value we will do or we will obtain while we are trying to deal with these logical connectives. Okay, let's see. Here we are having three words. One is a tautology, then contradiction, then contingent. Okay, tautology, contradiction, and contingent. Okay, so what is a tautology? Tautology is a truth value of a compound statement or an argument, okay, containing the truth values as all true. Okay, so a statement that is true by necessity or it is true by virtue of its logical form, is, is said to be a tautology. For example, I am giving you one example of a tautological statement. Suppose we are having P or not P. P or not P. Okay. So P is a single statement. So P will have two truth values. So one will be true and other will be false. Is not it? So P will be true and it will be false. So if P is true, negation P will be false.
False.
If P is false, negation P will be true.
True.
So here, what will be the truth value of disjunction? It is
True.
true and it is true.
True.
Okay. So P, disjunction negation P is a tautology. Okay.
Hmm.
Okay.
Yes.
Similarly, P conjunction P, P conjunction not P, is always a contradiction. It contains false as all its truth value. Okay. I'm just explaining you what is tautology and what is contradiction. Okay. So whereas P conjunction Q will be a contingent proposition, will be a contingent proposition which will contain both true and false as its truth value. Okay. So this contains both true and falsity. Therefore, P conjunction Q is a contingent proposition. Okay. So this the difference between tautology, contradiction, and contingent. Tautology is when the truth value of the proposition is all true in every condition, then that is tautology. Contingent is when the truth value of a proposition is false in all conditions, and contingent is when the truth value of the proposition has mixed to values of truth or falsity. Am I clear?
Yes, it is clear.
Okay. Now just let me share with you another uh, example where Can you see this? Or I will share this by rotating it. Is it visible? Please tell me.
Yeah.
Is it visible?
Yes, it is visible.
Yes. See, here in this 5, 6, 7, 8, 9, 10, it tells that, or it asks that, find out which of the following, what are the truth tables of these uh, statements, whether it is a tautology or a contingent or it is contradictory in nature. Okay, so here in the fifth one, P implies P conjunction P. Tell me what will be the characteristic of this statement. Do it. Pankajini, এটা তুমি কুহ কোন হবো?
ହଁ ମ୍ୟାମ୍ ମୁଁ କହୁଛି।
କୁହ।
Is it tautology?
Yes, it is a tautology. Pankajini ହେଲା ଏଟା?
ମ୍ୟାମ୍ ଟିକେ ନୋ ମ୍ୟାମ୍।
କଣ ହେଲା ଅସୁବିଧା କୁହ?
ମ୍ୟାମ୍ ମ୍ୟାମ୍ ମାନେ ଏବେ ସ୍କୁଲ ଟାଇମିଂ ତ ସେଥିପାଇଁ ଟିକେ ମାନେ ମୁଁ କ୍ୱେଶ୍ଚିନ୍କୁ ଟିକେ ମାନେ କରିବାକୁ ଟିକେ ଟାଇମ୍ ମାନେ ଇଏ ହେଇଯାଉଛି, ତ ସେଥିପାଇଁ ମାନେ ମୁଁ ଠିକ୍ ସେ ଶୁଣିପାରେ ମାନେ ଆନ୍ସର୍ଟାକୁ ଇଏ କରିପାରୁନି।
ଆଚ୍ଛା, ଏଠି ଦେଖିଛି ଯେ P implies P conjunction P ହେଲା, ତ
ହଁ
P ର
ମ୍ୟାମ୍।
ଦିଟା ଭ୍ୟାଲ୍ୟୁ ରହିବ, ଗୋଟେ ଟ୍ରୁ ରହିବ ଗୋଟେ ଫଲସ ରହିବ
ହଁ
ନା ନାଇଁ? ସପୋଜ ଏଠି P ହଉଛି ଟ୍ରୁ, ଏଠି P ହଉଛି ଟ୍ରୁ, ତ କଞ୍ଜକ୍ସନ କଣ ହବ?
ଟ୍ରୁ ହିଁ ହବ।
ଟ୍ରୁ ହବ, ତ P ଟ୍ରୁ implication P conjunction P true, implication ଟା କଣ ହବ? both side ଟା true ଅଛି।
ବହୁତ ସାଇଡରେ ଟ୍ରୁ ଅଛି ତ ସେଠି ଟ୍ରୁ ହିଁ ହବ।
ହଁ, ତ ଏଇଟା କଣ ହେଲା? ଟୋଟୋଲୋଜି ହବନି? ଏଠି ଯଦି ଫଲ୍ସ ବି ଲଗେଇଲ
ହୁଁ
ତାହେଲେ ନେକ୍ସଟ
ହଁ
ଟ୍ରୁଥ ଭ୍ୟାଲ୍ୟୁ ହଉଛି ଫଲ୍ସ, P ଫଲ୍ସ ରହିଲା ସେକେଣ୍ଡ ରେ, ଏଠି P ଦିଟା ଯାକ ଫଲ୍ସ ମାନେ କଞ୍ଜକ୍ସନ ଫଲ୍ସ ରହିଲା ହେଲା, ତ ଇମ୍ପ୍ଲିକେସନ ର ବୋଥ ସାଇଡ ହଉଛି ଫଲ୍ସ, ତ
ହୁଁ
ଇମ୍ପ୍ଲିକେସନ ଟା ଟ୍ରୁ ହିଁ ହବ।
ହୁଁ
ହବ ନା ନାଇଁ?
ହଁ ହଁ
ହବ ତ?
ହୁଁ
Okay. Amrish, are you able to do the rest?
I can do. I think
Yes.
I will be able to do.
Yes. So let's move to this double I,
Mhm.
where it is asked that use truth tables to decide which of the following are logical equivalences. Okay. What is logical equivalence? This is the sign of logical equivalence. Okay.
Mm.
This is the sign of logical equivalence. Okay, so here P implies Q. You have to see whether P implies Q is logically equivalent to negation P implies negation Q. Okay, that means the truth value under the implication sign here in left hand side will be similar to the truth value of this implication side on the right hand. Okay, so I did this. I am just sharing with you how you will do this. Okay,
Ma'am, this is from that fifth edition book of symbolic logic
yes,
from
yes,
Gopi.
yes,
Okay.
yes, yes. Is it visible? Please tell me.
Yeah.
See, here we are having two variables, we will have four rows. Instead of one, true T and F, I have written 1 and 0. 1 for true and 0 for false. Okay, did you get it?
Yeah.
Okay.
Yes, ma'am.
See, in P implication Q, here in the very last variable, under the last variable we are having one set of 1 and one set of 0. Okay, 1 0 1 0, and in the second variable we are having two sets of 1 and two sets of 0. Okay, so here the implication is simple. You have to just put the truth value of implication and you go to the right hand side where if P is true, not P is false. Okay, so as per the truth value of P, we have to decide the truth value of negation P, and as per the truth value of Q, we have to decide the truth value of negation Q, and accordingly you have to decide the truth value of the implication sign. Okay, so you can see that here we are having 1011 and here we are having 1101. Okay. So now let, let us put the truth value under equivalence sign. As we have said that equivalence will be true when both the LHS and RHS are having same truth values. So here it is true and here it is true, therefore equivalence is true. Okay, and here it is false and it is true, it is false. Here it is 1 and it is 0, it is false. Here we are having both as true, therefore it is as true. Okay, so if you look into this combination, you can easily identify whether these two statements are logically equivalent with each other or not. Though we are having here one falsity and two truths, oh sorry, one for falsity and three condition of truth, and here also we are having one falsity and three conditions of truth, but the combination of this truth and falsity varies. Okay, therefore तार तो मुझे कौन कहना चाहूँगी ना एठी जदियो गोटे कंडीशन अछि फॉल्स होबार और तीनटा कंडीशन अछि ट्रू होबार ए केस रे भी सेया किंतु ऑल दिस कंडीशंस वैरी जदि आर जो भाबरे 1011 अछि जदि एटा सेही भाबरे 1011 थांता ताहाले एटा इक्विवेलेंट हे थांता बुझी पारलो बुझियला
Yeah. Yeah.
ओके you just do the next one two, you will see that it will you will find the logical equivalence there. Do the second one.
Ma'am, can you show the?
Uh-huh. Just wait. Is it done?
Yeah,
See, I have shared with you.
yeah,
Okay. So it is logically equivalent.
yeah.
Okay. Now next we move on to another discussion, that is, just let me cross these things, that is rules of deduction. Okay.
Ma'am, can you also little tell about where are these applied, like the application of this much of this whole construct of logic in these terms?
See, these are all very much concerned with the logic in itself. Okay.
Right.
So logic, you in philosophy, logic is used as an instrument. Okay. So in philosophy of language or in analytic philosophy specifically, they use logical analysis as an instrument to remove the misunderstanding from the everyday language. Okay, so it is necessary. So and logic in itself is having its own norms and its own symbols. So through these symbols and rules, they say that it will be easier for us to understand the language in a better way, so that we can remove or we can solve certain philosophical problems. Okay.
Okay, like this is the grammar of philosophy.
Oh, you can say so. This is
Mhm.
the grammar of philosophy. Yes. Okay. Let me share with you another very important point. Uh, in Google Meet, I can't send you the images now. Can I? I don't think so. Okay. Re- Here, can you see this? Is it visible? Is it visible?
Yeah, to some degree.
Okay. See, in deduction is a procedure by which, by deriving the conclusion from the premises, we deduce that the argument is valid. Okay. So here, these are certain rules that we have to follow while we will do the deduction. Okay. And by following these rules, we will see whether the conclusion follows from the premises or not. Okay. So, first, there are 9 rules which are called as rules of inference. These are called as rules of inference. Okay. And you have to remember these rules while you will do the deduction, right? The first rule is modus ponens. Can you see it?
Yes, ma'am.
Okay. The first rule is modus ponens. Now listen very carefully. I am just explaining these rules to you. Modus ponens is a rule where if we are having a argument in which the first premise is P implies Q, and in the second premise we are having the antecedent of the implication that we are having in the first premise, then we can deduce the conclusion. Okay, I'm repeating. In modus ponens, the argument in which the premise is, the first premise is P implication Q, where P is the antecedent and Q is the consequent. And in the second premise, we affirm the antecedent, that is the P. Then, in conclusion, we can affirm the consequent. Okay? So P implies Q, P, therefore, we can deduce Q. Okay? Is it clear? Is it clear? Please tell me.
Uh, so this is like a rule that if P implies Q in the first premise and second it's P, then therefore we must say it is conclusion should be Q.
Yes. So, in order to derive Q, you need to have P implies Q and P. Otherwise, you cannot derive the consequent in the conclusion. Okay?
Okay.
So, that is the first rule of deduction. The second rule is, if in an argument the first premise is implication, that is P implies Q, and in the second premise we deny the consequent, then in the conclusion we can deny the antecedent. Okay, so if the first premise is P implies Q and the second premise is negation Q, then in the conclusion we can derive negation P.
Negation P or negation Q?
Negation P.
This is what is this name of this rule?
You see, this is called modus tollens. MODUS TOLLENS. Modus tollens. Okay.
Okay.
So in the very first rule, modus ponens, what we did is that in the first, if the first premise is it is in implication form, and in the second premise we affirm the antecedent, then in the conclusion we can affirm the consequent. Okay, but we cannot deny the antecedent and deny the consequent. That will be a fallacy. Okay, so if we are having P implies Q and in the second premise we are having negation P, from that we cannot have negation Q. So by denying the antecedent we cannot deny the consequent. Okay. Similarly, in modus tollens, where we are denying the consequent, by denying it we deny the antecedent. Okay, the other way around cannot be possible. That means by affirming the consequent we cannot affirm the antecedent. That will be a fallacy. Am I clear?
Ma'am, can you repeat this both cases
Yes.
again?
See, in modus ponens, what we are saying is that if we are having the first premise in an argument, if we are having the first premise as antecedent and the second premise we affirm the antecedent, and by affirming it, in conclusion we affirm the consequent. Okay, this will be a valid rule. Okay, but we cannot we cannot deny the antecedent in the second premise and deny the conclusion. That will be a mistake. Okay,
So if we cannot deny in the second premise the antecedent and deny the consequent in the conclusion,
Hmm.
then this would be a fallacy.
Yes.
Okay. Only so it's like a exception to
Yes.
highlight that this is a fallacy in such a case.
Yes. Okay. Similarly, in case of modus tollens, so we are having P implies Q, then we deny negation Q, or then we deny Q. By denying it, in the conclusion, we deny the antecedent. Okay. So we cannot do it otherwise, like by affirming the consequent, we cannot affirm the antecedent. Okay. Next is hypothetical syllogism. Hypothetical syllogism is if we are having the first premise as P implies Q and the second premise as Q implies R, then in the conclusion we can say P implies R. Okay. So in the first premise, we are having P is the antecedent and Q is the consequent. And in the second premise, Q becomes the antecedent and R is the consequent. Then we can derive that P implies R. Okay.
Yes.
Next is your disjunctive syllogism. Disjunctive syllogism. In disjunctive syllogism, in the first premise, we are having P disjunction Q, and in the second premise, we are having negation P. Then we can derive Q. Okay. Or if you deny the Q, then also you can derive P. Is it clear?
Yeah.
That means,
So
suppose we are having X is either in Bhubaneswar or in Cuttack. Okay. Then we are having X is not in Bhubaneswar. Therefore, X is in Cuttack. Or if we are saying X is not in Cuttack, therefore X is in Bhubaneswar. Okay.
yes.
Okay. Then there is next rule is constructive dilemma or CD. Constructive dilemma or CD. Okay. In constructive dilemma, in the very first premise, we are having two hypothetical proposition joined by the logical connective conjunction. For example, we are having P implies Q in conjunction with R implies S. Okay. So in the first premise, we are having two hypothetical or conditional propositions joined with the logical operator or logical connective conjunction. Okay. In the second premise, we disjunct both the and both the antecedents of both the conditional statements. Can you see it? In P implies Q, the antecedent is P, and in R implies S, the antecedent is R. In the second premise, what we did is that we disjunct the first antecedent and the second antecedent, then the conclusion we will derive is the disjunction of the consequence, that is Q or S. Okay,
Yeah.
this is linked with your modus ponens, as you can see. So the opposite of the constructive dilemma is the destructive dilemma or DD, where we are having two hypothetical propositions joined with a logical connective conjunction, and here we we disjunct the negation of the consequence. That is, in P implies Q, Q is the consequent, and in R implies S, S is the consequent, and we disjunct. If there is a disjunction of negation of both the consequents, that is negation Q or negation S, then we derive that the negation of the antecedent joined with the disjunction connective. Okay, that is negation P or negation R. Is it clear? Can you see it?
Yeah. Uh,
Next is, which is a very easier one, is simplification. In simplification, we are having a single premise, that is P conjunction Q, and from P conjunction Q we can derive P or we can derive Q as well. Okay. So P conjunction, it should be in conjunction form. Simplification is only applicable to the conjunction only. You cannot apply simplification in case of disjunction, implication, or equivalence. So if two propositions are joined with conjunctive operator or conjunction, then through the rule of simplification we can derive one of the conjunct. Okay. The next rule is conjunction. The conjunction rule says that if we are having two propositions in both the premises, the premise 1 contains a proposition P and the premise 2 contains the proposition Q, then in conclusion we can have the conjunction of both the propositions, that is P conjunction Q. Okay.
yes.
Then the ninth rule is named as addition. Okay. Here, if we are having a single proposition as a premise, then through the rule of addition, we can derive P or Q. Okay. So addition will be only through the disjunction connective only. We cannot add through conjunction or through implication. So addition is only use the logical connective, that is disjunction. Am I clear?
Yeah.
Okay. You just take a picture of this. You just take a picture of this so that I will move on to the next page. Are you done?
Yes.
Okay. See, is it visible, Amrish?
Ma'am, can you zoom it a little bit?
Okay, I'm doing it. I'm already zooming it. You can't see it, no?
It's a little difficult.
Okay. What?
Okay, let me see.
You just take a picture of it, right?
Yeah,
And zoom it.
yeah.
Everyone, please take a picture of it and zoom this and try to understand what I am trying to say.
Yes, ma'am.
See, in exercise 1, you have to identify which of these rules are applied. Okay? By which the conclusion follows from the premises. In question 1 to 15, you just need to see which of these 9 rules have been applied by which they derive the conclusion from the premises. Are you getting me?
Yes, ma'am.
Okay. See, in the very first exercise, A implies negation P, conjunction, negation C implies D. And the conclusion is A implies negation B. Can you identify the rule by which the conclusion is derived from the given premise?
Can you tell the page number? I will try to open it in the book because I'm not able to see properly. Yes.
So it is the page number is 35 if you are having the 5th edition.
Okay, I will try.
Or else, let me just take a picture of it and
Yeah, I think I found in fourth edition. I found the page.
you got it.
Yeah, I think so. C20. Okay, this is, yeah. Yeah, I got it in the fourth edition book.
Okay.
So is it simplification?
Yes, very good. It is simplification. ପଙ୍କଜିନୀ କିଛି ବୁଝା ପଡୁଛି?
ହଁ ମ୍ୟାମ୍।
What is the second one? Is it now clear? Pankajini or others?
Yes, ma'am.
See, this is given E implies negation F, and the conclusion is E implies negation F or negation G implies H. Tell me which rule is applied.
Addition.
Yes, addition it is. Okay. Now let's move to the this one. This exercise 2, double I. Here the deduction is done. Okay. So in the steps you have to identify by which rules they have deduced the deduction. Okay. So see, in the premise 1 it is given a conjunction b implies a implies d conjunction e. So there are two premises, the conclusion is d or e. Amrish, can you see it?
Yes, I can see.
Okay, so there are two premises only and there is one conclusion. Okay, so now from the premise 3 to 8. Okay, from premise 3 to 8 you just have to identify the procedure, the rules by which these steps are being obtained. Okay, so if you see the premise 3, the premise 3 is derived from the premise 1 through the rule of simplification. Is that it? Sorry, premise 2. The premise 3 is derived from the premise 2 by the rules of simplification. Is it clear?
Uh, Premise 3 is A dot B. This one
Ha ha ha.
is derived from 2, where it's 40. Okay.
Okay. So the
Like,
rule of simplification is applied in premise 2.
uh-huh.
Okay. Now see the premise 4. The premise 4 is derived from premise 1 and 3 by the rule of modus ponens.
Yes.
Okay.
Yes.
Now the premise 5 is derived from the premise 3 through the rule of simplification.
Yes.
Now the premise 6 is derived from the premise 4 and 5 through the rule of modus ponens.
Which number you are saying now?
6, 6.
6.
6 is derived from 4 and 5 by the rule of
Yeah.
modus ponens.
Yes. Yes.
Okay.
Yes.
Now the premise 7 is derived from premise 6 through the rule of simplification.
Yes.
Then the premise 8, which is the conclusion, is derived from the premise 7 by the rule of addition.
Yes.
Okay?
Yes. Oh.
Okay.
Yes.
So this is easy. You don't have to do the deduction. Deduction is done, but you have to identify the rules.
Yeah.
But in next, there is the exercise where you have to symbolize the argument, then you have to follow the You have to, by following the rules, you have to derive the conclusion. Okay. In exercise 3, you can see the construct a formal proof of validity for each of the following argument, where you have to apply the rule of deduction. Okay.
So what does it mean, construct a formal proof of
The
validity?
way it is done in question double I.
Uh-huh.
Okay, it is already done in double I. In that way, you have to do it here. Are you getting it? Let me just do one for you, then it will be easier for you to understand it.
Also, ma'am, is there any relationship between the subject of mathematics and logic? Like,
Yes, yes,
how do
they
we?
are related.
Okay.
Okay. Is it visible?
Yes, it is visible.
See, in premise 1, 2, 3 are given, and we have to derive the conclusion negation A or negation C. Okay. Can you see it?
Yes.
So the premise 4 is the simplification of premise 3. Okay.
Yes.
And the premise 5 is the conjunction of premise 1 and 2. Okay.
Mm-hmm.
Then the premise 6, here we apply the constructive dilemma rule, because you can see in A implies B, B is the consequent, and C implies D, D is the consequent. And premise 4, you can see the negation of the consequent B is disjunct with the negation of the consequent D. So as per the rule of constructive dilemma, we can derive the negation of the antecedent A disjunct with the negation of the antecedent C. Okay?
Yes.
So in this way, you have to do the deduction.
Hmm.
Is it clear?
So we have to basically utilize the given rules and deduce from that the next step.
Yes, yes. Okay. So in addition to these rules, we are having another set of rules. Okay. This. This is, you can't rotate it in WhatsApp. Let me take a picture. Okay, there are another 10 rules which are called as rules of replacement. Okay,
Yeah.
and all these rules you have to follow by you have to follow while you do the deduction.
Okay, so these 9 rules plus these 10 rules.
Yes.
Okay.
Why it is coming in this way, horizontally?
So I have got it in my book on these rules.
Okay. So all these rules you have to apply while you are doing the deduction procedure. Okay. So this is it is not quite um, feasible to to do the deduction here in this manner. So I will just state the rules. What are the rules of replacement? And in the by following or applying these rules, we have to follow the deduction procedure. Okay. Next is,
Though, so these 9 rules are called rules of inference
yes,
within
these are the
the,
very preliminary rules.
but
Okay.
they are used for deduction, but they are called rules of inference.
Yes.
Okay.
Another set, the 10 rules, they are called rules of replacement because they follow the logical equivalence relation. Okay. For example, if you are having a proposition P implies Q, okay, then this P implies Q is logically equivalent to, sorry, if you are having the proposition P implies Q, then this is logically equivalent to negation P or Q. Okay, negation P or Q. That means you can replace P implies Q instead of or by the proposition negation P or Q because they are logically equivalent to each other. If you do the truth table, you can see the truth value of this implication and the truth value of this disjunction are similar. Therefore, they are logically equivalent. The equivalence will always be a tautology. Okay, so that is why they are to be called as rules of replacement. So if there is a proposition P implies Q, in there instead of P implies Q, you can write negation P or Q. Okay, similarly the negation P or Q can also be written in the form of a conjunction. Okay, by following the rule of De Morgan. Okay, so therefore they are to be called as replacement rules. Are you getting me, Amrish?
Yes, yes.
Okay.
Understood.
Okay. So another method, this is one of the method of doing the deduction where we try to derive the conclusion from the set of premises by following the rules of replacement and the rules of inference. Another method of testing the testing the invalidity of the argument. Mark me, I'm saying that testing the invalidity of the argument. So when an argument will be invalid. Okay. Listen carefully. If we find in an argument where all the premises are true and the conclusion as false, then that argument is invalid. Did you get me?
One more time, please, ma'am.
If in an argument all the premises are true but the conclusion is false, in that argument or this argument is an invalid argument. Okay, or in an invalid argument the premises are true and the conclusion is false. Okay,
Okay.
so let me show you something to make this understandable. Okay, suppose we are having an argument here. Is it visible?
Yes.
Okay, so this is an argument. Here we have to symbolize it. Okay, let me symbolize this. The first proposition is if the seed catalog is correct, let me take it as S, then then is the symbol of implication S implies, then next is if the seeds are planted in April, A, then implication the flowers bloom in July, let it be J. Okay, now the second premise is the flowers do not bloom in July. negation j. Therefore, therefore, if the seeds are planted in April A, then the seed catalog is not correct. Negation S. Is it clear?
Yes, it's clear.
It's clear, no?
Yeah.
Okay. Now we have to check whether this argument is a valid argument or it is an invalid argument. Okay. So here we need to draw a truth table in order to check the validity or invalidity of the argument. And in that very truth table, if we find a row where we see the premises are true and the conclusion is false, then we will derive the conclusion that the argument is an invalid argument. Okay, so here this is the first premise, and this is the second premise, and this is the conclusion. Okay, how many statements we are having? We are having three statements. Okay, so since we are having three statements, we will have 2 to the power 3. That means we are having 8 rows. Isn't it?
Yes, yes.
Okay, let me draw the table. So for the three propositions, we are having 1, 2, 3. Then for the first premise, we are having one column. For the second premise, we are having one column. And for the conclusion, we are having one column. We are then having 1, 2, 3, 4, 5, 6, 7, then 8, then 9 rows. Okay. So the first variable I am taking, is S. The second variable I am taking as A. The third variable I am taking as J. Okay. Then there will be the first premise. Okay. Then there is second premise. Then the conclusion. Okay. Am I clear?
Yes, it is clear.
Okay. So here what will be the truth value under J? That will be one set of 1 and one set of 0. Okay. 1, 0, 1, 0, 1, 0, 1, 0. How many it is there? Okay. Okay. In the next variable, we are having two sets of 1 and two sets of 0. 1, 1, then 0, 0, 1, 1, then 0, 0. In the third variable, we will have 4 sets of 1 and 4 sets of 0. 1, 1, 1, 1, 0, 0, 0, 0. Okay. Now, it is very easier for us to have not j because we are having the truth value of j. So this will just be the reverse of what is there in j. Okay, is it clear?
Yes, yes,
Okay, now for to get the first premise, first we need to have a implies j, is not it?
yes,
So let me insert another column to have the truth value of a implies j. Okay, so a implies j. As per the rule of implication, if the antecedent is true and the consequent is false, the truth value is false, otherwise true. So you have to check where the antecedent is true and conclusion is false. There you just put 0. Then in rest we will have truth value as 1. Okay? Is it clear?
yes,
Next, we will have S implication A implies J. So we have to tally this column with this one. Okay, S with A implies J. Look at where antecedent is true and consequent is false. Here 1, 1, we will have 1. 1, 0, we will have 0. Try to, in case of 1, 1, 1, 1, 1. Here you are having antecedent all zeros, so you don't need to recheck. So we just put 1, 1, 1. Let me have some more. Okay, am I clear so far?
yes,
Okay, this is done. Okay, so the first premise and second premise we have done with this. Okay, now let's move to this conclusion. In conclusion, we are having negation S. So we now need to have the truth value of negation S. Okay, so let me here just have another row, not here, here only, for negation S. Okay, so whatever S is, the reverse will be the negation S. So 0, 0, 0, 0, and Let's see. 1 1 1. Okay. Now here A implies not S. A implies not S. Okay. So here 1, A is 1, not S is 0. So here you will have 0 as truth value. 1 0 0 0 0 1 0 0 1. Okay. 1 1 1 1 0 0. So we will have 1, we'll have 1 1 1. Okay. So this is done. Is it clear?
Yes, it is clear.
Okay. Now just see, you just find out a row where the premises are true and the conclusion is false. Okay. So here you see, this is the first premise, this is the second premise, and this is the conclusion. Okay. So here premise 1 is true, premise 2 is false, conclusion is 0. So it's all right. Now this one is also, premise is false, this one is true, this one is 0. And in rest of the rows, you see the conclusion is true. Therefore, it is not required to check all this, because we have the rule that where the premises are true and the conclusion is false, then the argument will be an invalid argument. Okay. So this argument, we didn't find any row where the premises are true and the conclusion is false. Am I clear?
Yeah, yeah. Understood.
Okay. So therefore, this argument is a valid argument. Okay. Okay.
Yeah, it is clear.
So now this test of invalidity in the okay. See, here there is an argument which is given. Okay. And here we have to check whether this following argument is invalid or not. Okay. This is the premise 1. This is the premise 2. And this is the premise 3. Okay. Here this is a method of checking invalidity, and this is another method of checking invalidity. Okay. So here what we need to do, we know that the argument is invalid when the conclusion is false and premises as true. Okay. So here the conclusion, what we will do, we take the conclusion as false. Okay. We take the conclusion as false, and we take the premises as true. Okay. Then we put the values of its constituents. So J implies N is false when J is true and N is false. Am I right?
Yes.
False. Okay. So wherever j is there, we just put whatever value we got. N, here it is. Okay. Now we need to try to make the premises true. Okay. So here you can see in the first premise that our implication is true and antecedent is true. Therefore, the consequent cannot be false. It has to be true. Okay. It has to be true. Now, for implication, we need three conditions for which implication is true. So before doing this, let's go back to or move towards the third one, where the consequent is false. Therefore, here the antecedent cannot be true, rather it should be false. Okay. And since it is disjunction, therefore there is only one condition in which disjunction is true. That is, if both the disjuncts are false, then our disjunction is false. Okay. So here we got all the values. Okay. So here L is false. Here we are having not L. So not L will be true. And M we got as false. Therefore, it will be false. So here the implication will be false. Okay. So since this one is false, here K we cannot take as true. K need to be false. Okay. So K false. L is 0. So there is no discrepancy or there is no inconsistency we find while we are trying to put the truth values of these constituent propositions of the argument by taking the conclusion of it as false and premises of it as true. Therefore, we derive that the argument is invalid argument. Is it clear or not? Tell me.
Ma'am, we didn't find any inconsistency, so
Inconsistency, why we didn't find any inconsistency? Because we take the conclusion as false.
oh, okay, okay.
Therefore, this is an indirect way of proving the invalidity.
Oh, okay, yeah, it's yeah,
Okay.
yeah.
Is it clear?
Yes, yes.
So here we do not find any inconsistency while putting the statements, okay, by taking the premises as true and conclusion as false. Therefore, the argument is invalid. Okay. The same procedure is there in case of another method that we are having called reductio ad absurdum. Okay, that is called as reductio ad absurdum. Okay, the technique is same. You have to take the conclusion as false and premises as true. Then you have to put the values of the constituent proposition of the argument. Okay. And if you do not find any inconsistency in putting the values of the constituents, then you derive the conclusion that the following argument is invalid because we put the conclusion as false and the premises as true. If there will be any inconsistency, then the argument is said to be a valid argument. Okay, is it clear?
Just last statement one more time. This about reductio ad absurdum.
This is the method of reduction ad absurdum only. Okay,
Okay.
in reduction ad absurdum, what we will do in the argument, we take the conclusion as false and premises as true. Okay,
Okay.
and after doing this, we try to put the values of the constituent propositions. Okay, and while doing this, if there is no inconsistency arise, then we derive the conclusion that the argument is an invalid argument. But if there is inconsistency in putting the values of the constituents arise, then the argument will be a valid argument. Is it clear now?
Yes. Yes.
Okay. So far, this is the proving of invalidity so as the reductio ad absurdum method. Okay. Another method is called as conditional proof. Another method is called as conditional proof. Okay. In conditional proof method, this is also another way of proving the validity. But in this method, what we are actually doing is that, and this conditional proof is applicable to the arguments in which the conclusions are conditional in nature. Okay, the conditional proof can be applied to those arguments, the arguments which are having the conclusion which are conditional in nature. Am I making sense?
Yeah.
Okay. So if the conclusion is in conditional form, then what we will do is that we take the antecedent of the conclusion as a new premise and we derive the conclusion. Let me show you one with the example. Okay. See this one. Is it visible?
Yes.
Okay. See, this is, there is one premise and this is the conclusion, this is the conclusion. So conditional proof, what it is saying, if the conclusion is in conditional form, we have to take the antecedent of the conclusion as a new premise. Okay, so what is the antecedent? Antecedent is U or W. Okay, so here we need to write that this is the additional premise. So what conclusion we left? We left with only B or X. Isn't it?
Yeah.
So we have to prove V or X. We don't need to prove now this original or the given conclusion, because as per the rule of conditional proof, the conditional proof is only applicable to the arguments which are in conditional form. Okay. So there we take the antecedent of the conditional statement as a new premise, and we prove the left whatever they are left in the conclusion. So here how we will do the deduction. So the premise 3 will be C, U or W. So the conclusion will be V or X as per the rule. This is very easy. V or X as per the rule. How it is? This is from 1 and 2 by the rule of constructive dilemma. Okay. So here antecedent is disjunct in the second premise, and we derive the disjunction of the conclusion. Is it clear?
Yes.
Okay. So far another thing is left. That is your quantifier. What should I do?
Ma'am, we can study that, and if we have doubts, then we can have some doubt session on that.
Yes, you just talk with your sir. Okay. Then accordingly we will plan. Okay.
Which sir?
I don't know. You have to talk to Panikrai sir, I think.
We don't have any contacts. Any
Oh, I will
like
talk to him. I will talk to him. Okay.
yeah.
Okay.
Okay.
Okay. Bye,
Okay. Thank you, ma'am.
everybody. Okay.
Thank you, ma'am.